Genevieve speaking. This is a presentation on how to select a simple random sample from a finite population. We have a finite population when the number of elements in the population is a finite number. For example, the population of 2,500 managers in a company. It is finite. We know who they are and how many they are. The population of tires produced by that company refers to all the tires that could potentially be obtained from a production process. That population is not finite. When the population is finite, we can list all the elements in the population. We call that list a frame. A single random sample of size n from a finite population is defined as one such that each possible sample of the same size has the same probability of being selected from that population. To select such a sample, we can use a table of random numbers such as table 7.1. This is our Excel file of our 2,500 managers. We constructed a frame by assigning each manager a number from 1 to 2,500. Next, we refer to the table of random numbers. Using the first row of the table, each digit 6, 3, 2, 7, 1, 5, 9, and so on is a random digit having an equal chance of occurring. Because the larger number we assigned to our managers is 2,500, which is a number with 4 digits, we select random numbers from the table in sets or groups of 4 digits: 6,327, 1,599, 8,671, 7,455, 1,102, and so on. So note that we could have started the selection of random numbers anywhere in the table and move systematically in any direction of our choice. Here we used the first row and moved from left to right. Because the numbers or digits in the table are random, these 4-digit numbers are also equally likely. We can now use these 4 digits random numbers to give each manager in the population an equal chance of being included in the random sample. First number, 6,327. It's greater than 2,500, so it does not correspond to one of the numbered managers in the population. We discard it. The second number, 1,599, is between 1 and 2,500. So the first manager selected for our random sample is manager numbered 1,599 on our list. Continuing this process, we ignore number 8,671 and 7,445 and identify manager numbered 1,102 from our list as the next manager selected for our random sample. This process continues until the simple random sample of 30 managers, for example, is obtained. Note that in implementing this simple random sample selection process, it's possible that a random number used previously may appear again in the table before the complete sample of managers has been selected. But because we don't want to select a manager more than one time, any previously used random numbers are ignored because the corresponding manager is already in the sample. Selecting a sample this way is referred to as sampling without replacement. So when we refer to simple random sampling, we assume that the sampling is done without replacement. But where did the random numbers in table 7.1 we just used in our process, where did they come from? A quick Bing search on generating random numbers will lead you to Wikipedia page. Among others, a random number generator is a computational or physical device designed to generate a sequence of numbers that cannot be reasonably predicted better than by random chance. Many applications of randomness have led to the development of different methods of generating random data. This search will also lead you to finding out that there are true random numbers and pseudo-random numbers. According to the AbleBits.com tutorial, Excel, like most computer programs, generate pseudo-random numbers that are fine, just fine for many purposes. According to Microsoft.com support page, the algorithm used in Excel to generate random numbers passes a battery of tests, including tests developed by the National Institute of Standards and Technology, and the algorithm used in Excel to generate random numbers is also used in the software package provided by the Office of the Inspector General in the US Department of Health and Human Services. So the function used in Excel is the ran function, which returns an evenly distributed random real number greater than or equal to 0 and less than 1. The ran function has no arguments. Another one is a ran between. The ran between function returns a random number between the arguments we specify. Here, using Excel, we replicated table 7.1. This is not an exact replica because by definition we couldn't possibly generate the exact same random digits. Each digit was generated by instructing Excel to generate a random digit between 0 and 9. So we don't have to use the table of random numbers. We can use the ran between or ran function directly. To show how to do this, we're using the Met Areas dataset, which is a list of the top 100 metropolitan areas in the United States and Canada in year 2000. So this is also explained on how to do this in the appendix of chapter 7. Let's assume we'd like to select a simple random sample of 30 metropolitan areas. First, we add a column so we can number the metropolitan areas from 1 to 100. We actually don't need to do that, but we do that here so we can explain how using the ran function directly in Excel is similar to the process used earlier with the table of random numbers. Next, we use the ran function to assign each metropolitan area a random number. Note that our 22nd metropolitan area on our list is Denver, Colorado, and we've assigned to it a random number 0.00273. Next, we sort our list of metropolitan areas according to the random numbers we drew. Where's Denver now? Found it? Looks like it's on top of our list because it got the lowest random number. Last step, we identify the first 30 metropolitan areas from the ordered list to form our random sample of size 30. So what did we just do? Instead of relying on the random digits from table 7.1 to randomly draw those numbers or numbered metropolitan areas, that's time consuming, we directly use the Excel function, the same that is used to generate the table 7.1 in the first place, and quickly identify a random sample of 30 metropolitan areas that got assigned the smallest 30th random number. Much faster. So let's demonstrate. We're going to assign each metropolitan area a random number using the ran function. So ran, copy down below. How many did we say we had? 100, okay. And then go to data, sort, and we want to expand. Let's do that again quick. So data, sort, and then there's the little window that popped up you couldn't see earlier. We want to expand to all of this area before we sort. Et voila. The first 30 we said, right, we wanted metropolitan area, so up a bit down further, are going to form our random sample. We're not getting the same sample of 30 metropolitan area as we did earlier using the random table, because we did not get the same random numbers. That's a very important point to remember. Each time we draw a random sample, we get a different sample. Also, it doesn't even look like Excel sorted the metropolitan areas from the lowest to the highest random number. The reason it doesn't look like it did is because each time we do an operation in Excel, a new random number is generated by the rand function. As explained in the rand function instruction, a new random real number is returned every time the worksheet is calculated. Let me show you. So if I use the random number function and then generate one number for each metropolitan area at a time, and when I do that, the random number previously selected above is going to change. Do you see that? One more time. The two above are going to change again. Microsoft support page suggests that if you want to use the rand function to generate a random number, but you don't want the numbers to change every time the cell is calculated, you can enter =rand function in the formula bar and then press F9 to change the formula to a random number. Let's go back to demo 2. So here, if I select one cell, you can see here in the formula bar that each cell has the formula =rand. Now let's do what the support page suggested. So select my rand function, I type my rand function, and then press F9. Here we go. See, now we have a random number that's generated. Move my cursor below, come back, and in my formula bar I see the random number as opposed to the formula. Back to our demo 2.1 worksheet. So once we got our sample of 30 metropolitan areas that we generated, we really don't need those random number anymore. And this concludes our presentation on simple random sample from a finite population.